On today's lesson, 8.3, the first day, we're going to be looking at exponential growth and exponential decay. Some real-life quantities can increase or decrease by a fixed percent each year. The amount, the absolute value of y of such a quantity, can be modeled down below. For exponential growth, y, whatever y is measuring, it might be money, it could be many other things, it could even be people in theory. We can talk about that later. Y is equal to a times parentheses 1 plus r to the t. If you read right down below, a is just a beginning amount, an initial amount. R is the percent increase or decrease, always written as a decimal. Exponential growth, we're always going to see that the quantity that we're measuring is going to increase. We're going to have a certain percent of growth every year. By way of comparison, we can take a look at exponential decay. Exponential decay is going to be this formula right here, looking very, very similar. The only difference, of course, is that we have a 1 minus r in the parentheses, so y is equal to a times 1 minus r, all raised to the t. T is measured in time. Many times it's in years, but it can be in different units. Down below, the quantity 1 plus r is called the growth factor. Similarly, 1 minus r is called a decay factor. Let's read example 1 together. One year, a clothing company had $1.5 million in sales. In later years, the sales, y, increased, and that word right here is going to definitely help us out. That increase is telling us that we have growth, but it's an increase of 25% each year. Write an exponential growth model that represents sales after t years. Well, using this formula that we see at the top of the screen, we're going to really use y, where y happens to be representing the number of dollars in sales. That's a times 1 plus r raised to the t. A is our beginning amount, or our initial amount. It's going to be right here, 1.5 million. A, very simply, is 1.5. Your r, you can always find your r because it's written as a percent. And we can see this is 25% each year. We don't write 25 though. We must write our percent as a decimal. Hopefully you remember that when we convert a percent to a decimal, we will always move our decimal place 2 steps to the left. So that's 0.25. We now have y is equal to 1.5 times 1 plus 0.25, all raised to the t. Inside our parentheses, we can actually add 1 plus 0.25 and get 1.25 raised to the t. Very importantly, occasionally kids ask if they can just multiply the 1.5 and 1.25 together right now. The answer is no. That would break the order of operations. You might remember the Please Excuse My Dear Aunt Sally acronym. You always have to deal with exponents before you would multiply or divide. Well, this is only part A. And part B, use this model, this equation that we just had, to predict the sales in 8 years. So we're going to let t equal 8. And we will have y is equal to 1.5 times 1.25 raised to the 8th. Now, what we can do immediately is just use our calculator and type in exactly what we see. 1.5 parentheses 1.25 caret raising to the 8th power. It doesn't work out to a whole number. It's about 8.94. So we see about $8.94 million in sales. So that's all we're doing. We're going to work with these two formulas up above. We'll write a general equation, then we'll plug in a particular time. Let's look at example 2. It says you buy a new computer for $1,500. That's what you're starting with. You might not be surprised to see that's your A. The value Y in dollars of the computer decreases by 40% each year. We have exponential decay. It's the green highlighted formula up above. And we're going to be asked to write a particular equation for that. So Y is equal to, parentheses, A first, pardon me, little a, your initial amount, times 1 minus R raised to the T. We mentioned earlier that your beginning amount, we're measuring dollar value of the computer, is $1,500. Your R is 40%, but of course we need to move our decimal 2 places to the left. R will be 0.40. Very simply, we will have 1,500 out in front, 1 minus 0.40, all raised to the T power. And again, 1 minus 0.40, we can reduce that inside the parentheses to 0.60. And here is our particular equation. Y equals 1,500 times 0.60 to the T. Well, for part B, the question is, can we estimate the value at 3 years? Well, and this is the sad thing, for so many things that we buy, whether it's cars or technological devices like computers, we see their values drop over time. And all you have to do is just type this in, seeing what our value of this computer would be 3 years later. 0.60 raised up to the third. Quite a drop. Your computer after 3 years would be $324. Quite a depreciation. Alright, well, on the back side, we're not going to have word problems. We're going to be asked to write a particular equation. Y equals AB to the X, but we'd like to know what number is filling in for A, what number is filling in for B. We have 2 ordered pairs that we know lie on our curve, 1, 6. And if we have 1, 6, of course that's an X and a Y. And if I have the equation Y equals A times B to the X, definitely plug in your value for Y, substitute in your value for X, and B to the 1, of course, is just going to be a B. Very similarly, we have the ordered pair 2, 18. Do the exact same thing. Substitute in your Y value of 18. Your X value is 2. And for a moment, we just look at this. 6 is equal to A times B, and 18 is equal to A times B squared. This is a system of equations, and what we will do is solve this by substitution. I'd like to solve for A and get A alone. By the way, we're going to do that for all of these problems. We're going to solve for A. A isn't alone, it's being multiplied by B. To undo a multiplication by B, we divide by B. Very simply, we will have A is equal to 6 divided by B. The whole purpose for writing this, though, is so that we can go to our other equation and substitute. Replace that A value in the second equation with what we just found, namely 6 over B. Now, of course, you have a new equation right now with just one variable, namely B's in it. B cancels with B squared and just leaves you with a B itself. You'll have 6B is equal to 18. Let's divide both sides by a 6 and get B is equal to 3. But then, like we do with our substitution problems, we come back and we'll substitute this newfound value back into this original equation. 6 divided by b, well, 6 divided by 3 is equal to a. That means that a, of course, is equal to a 2. Well, the original question was, what is a times b to the x? Well, now I know that a is a 2, b is a 3, and again, just reiterating, re-stressing here, it's so tempting to want to change that to y equals 6 to the x. Many times kids will say, well, why can't I multiply 2 times 3 right now and just get a 6? And the answer is you'd break the order of operations. One more and then we're through. As we look at number 4, you can see it's really the same problem. We have 2 comma 16 right here. Of course, this is an x value and a y value. We have y is equal to a times b to the x. Y is 16, but our x value here is a 2. Similarly, we have an ordered pair of 3 comma 64. Y again is a times b to the x. Y is 64, and your x is a 3. Again, keeping in line with what we were doing in the previous problem, and we'll be doing this for all of our problems, we're going to use substitution. In fact, what our ultimate goal is for all of these problems of this type, we'd like to solve for a. Let's divide both sides by b squared, and very fast we have a is 16 over b squared. Well, continuing on, if we make a quick substitution over here, our a is just 16 over b squared times b to the third. 3 b's up above, 2 b's down below. We could very simply do some canceling. 1 b is left. We have 64 is equal to 16b. Divide by 16, and b is 4. Well, substituting b equals 4, going back into this original equation that we just solved, b is 4, so we have 4 squared down below. But here we go with the order of operations yet again. You always have to deal with exponents before you divide. 4 squared is 16, and 16 divided by 16 is a nice and simple 1. So a is 1, b is 4. The final equation, a times b to the x, we have 1 times 4 to the x. Now, a 1 is actually nice and simple. It's always understood to be out in front of any expression. So if you'd really like to simplify this, you could just say, look, there's an understood 1 right there. Plain and simply, it's y equals 4 to the x. Well, I hope this is going well. Our next lesson is going to involve some financial formulas, but actually very similar work. Good luck.